So hello everyone. Good morning. Am I audible? Anyone please confirm?
Yes, you are audible.
Thanks. So, okay, let's wait for a few more minutes so that other people can join. Yeah, then we will start at 11:05. Okay. So yeah, good morning everyone. I'm just sharing my screen. So is my screen visible? Anyone please confirm?
Yes.
Yeah. Thanks. Okay, so I am sharing you the dataset link. Okay, on which you will work on the different classifier. Okay. So you can use this link to download dataset. So first of all, like who all are going to code with me? I mean, just a message so that I will wait for those people. Okay, like before going to the any step, before I'll wait for those people. Okay, so yeah, please message in the chat box, like or raise your hand or anything like that. Yeah, so Vivek is going to code along with me. Yeah, any person? Hi Jaydev. Uh, so by the way, hello. Okay. Kanika is also going to code with along with us. Okay, so three people we have already people agreed to code along with us. Okay. Okay. So yeah, Jadav, have you got the link? I mean, yeah, you can little later or
Yeah, I've got it.
yeah. Thanks. Okay. By the way, you have got I think in OP1 you got 96 without your normalization. So yeah, I did that. Yeah. So for the have you got the MLP OP2 score, OP1 score? What about all of you? Hello.
Sorry, what's the question?
So I was asking that have they released the OP1 score to all of you?
I haven't gotten mine.
Oh, so I think no one would have got that. So yeah, you have got the highest 96. So for this OPE, all the question after 22 is ignored. Question number 16 and all the question after 22 was ignored. So after that, I don't know what is your mark, but yeah, before even excluding that question, your mark was 96.
Okay, is it expected to release today, the scores?
I don't know. I mean, like the portal process, those process we don't know like how much time they take and
Fine, got it.
yeah, but that's your marks. I know because actually the same thing we did in MLT and MLP also like we were got the highest mark. We cross check that. I mean, top few people. So in that only we got to know that in MLT many people has done cheating and all. And yeah, but MLP people hasn't done anything. Yeah, genuine marks was there. So yeah.
MLT, there everything is inside the portal only, right? No collab or nothing.
No. But that's why cheating happened. I mean, there are loopholes.
Yeah. In collab, there is no scope.
Yeah. So people has done cheating there over there. So actually yesterday was there some things and all. Yes. Like they called those people like whoever has done cheating and all.
Out of curiosity, what is the percentage of people who cheated?
I 10 to 15 people like they were caught that they were caught redundant. Like we had proofs for those people.
For 10 to 15 people.
Yeah.
And how many appeared?
I think that would be around in MLP we had 400 people, so there would be I think around 500 I expect because MLP has always larger audience if we compare it to MLP.
So 2-3% roughly.
Yeah. Very few people say that. That's true. I mean, very few people. 2-3%. Yeah, same. Yeah. So I mean, yeah. So, but that one thing is, I would always tell about that IIT rules. So if someone gets caught in this, there are very bad procedures. All I think, Bharat will go little lenient, but the rules are very strict. Someone gets caught in this malpractice.
How they were caught? Means what was the modus operandi?
Yeah, sorry.
How it was caught? Means what was the modus operandi through which people were doing the cheating?
So there are bugs. That is what I would say. But don't discuss these things in like this. So yeah, okay. Maybe we can discuss after after the, when we can stop the streaming and after that we can discuss few other things. Okay. Let's not to discuss these things. Yeah, live. Okay, so yeah, let's start doing this one, and after that, we can discuss few other things also. Okay, so let's go with the collab. Okay, so first I have shared the data set. Okay, so how many of you have opened the data set? So yeah, for now, we didn't ignore that 14th question. So the thing was like someone is getting the error, they should know like how they have to handle that error, like whether they have to ignore those values and what or whatever they have to do. So whoever has done that, they have got the marks for that question. So for 14%, but for after all the question after 20 seconds, we ignored. And yeah, the marks was just like we can so total marks was around 68. So yeah, we converted it into 100. I mean, just by multiplying 100 by 68.
Again, I'm very curious. What is the distribution of the marks? What does it look like?
So we like see, initially it was I mean most of the people were between 20 to 40 only. So but after this I think yeah 10 to 12 50 marks for everyone increased. Like now people are around 40 to 50, 40 to 50 somewhere near to that. Most of the people
Okay.
are there. Yeah. So because I like I saw few college people are not able to remove that not any part also. Like so people were struggling in that, and there are some other issues also. Like because since now the all the, whatever the doubts, whatever the I would not say the doubts. Yeah, whatever the you have suggested the problems were there in that collab, or maybe it's a typo or whatever it is. So yeah, all those questions got removed. Okay, after that, actually, I would agree on that point that very few people does practice. Okay, I mean they don't do the practice also. There are people like who do the practices. I mean, just seeing the code. I mean, just simple code line of code also. Like when they start writing, no, they just fumbles. I mean, I saw a few people like they were asking like they were saying that they are not able to load data set. They are using the current. They are using the correct syntax. So it is like that when I saw that they was using pd.react CSV. But if they want to use that driving, then they had to convert that. And they had to modify that. I mean, they had to take the keys and all, or maybe they may also do like that. I mean, they can download the dataset and then upload that. But many people didn't know that also. So just think like here till now, like in many weeks we have shared the data in I mean in different ways we share the data, but still people were not able to do that. So a few things are like that also, and yeah, paper had paper had many issues.
So would you be able to release the OP collab?
For your collab or what? I mean,
No, sir, not our collab, our solution collab probably. I
yeah,
mean, our
solution
collab
collab.
also, if we can see it is good.
So I think your collab can't be released, but yeah, solution collab can be released. Solution
Yeah.
collab. I think yesterday only I shared the PDF version, but in that version I think only 10 or yeah,
Oh,
yeah,
it's
yeah,
there in Discourse, is it?
yeah.
Okay, sir.
But
I'll
yeah,
have a look.
in that one, yeah, we just removed the answers for after the question 14th or 15th, something like that.
Okay,
So,
sir.
so okay, let's go with this. Okay. So everyone loaded this data set, no? I mean, how many of you are done with this data set? I mean, you have opened, how many of you have opened the collab and yeah, uploaded the data set? Okay. Yeah, please do. Okay, guys. Yeah, two people done. Okay, I'll try to wait for 4 people. I mean, whoever is raised his hand. Okay, yeah, 3 done. Okay, 4 actually. Yeah. Okay, 5. That's good number. I mean, so 5 people will go data. Okay. So 6 people. Otherwise, yeah. Okay. So the First question is, my screen is visible now properly. Yeah. Simple.
Yes.
Yeah. Thanks. So yeah, I think today we have a number of engagement. So yeah. Okay. So first load the dataset and just cross check the, the different columns. Okay. Just to plot. Yeah. Just see the observe the dataset. How many rows are there? How many columns are there? Your shapes and all. So you can use this as a column name. Okay, so first the question is download the dataset and export it. Just take the shape and shape and all, and then Okay. So, just take the shape and after that do these 5 tasks. Okay. If anyone has any approach like how we should proceed with this collapse, so if anyone has any new approach, then they can also tell to make it more interesting, something like that. Anyone having any new approaches? Yeah, so you can speak also. How many samples are there? How many? So here we can see that we have 5 samples and the 5 columns. Okay, so first column is class, second column is left weight, third column is left distance, fourth column is right weight, and fifth column is right distance. So which one do you think would be your target variable? So anyone just. So class would be your target variable. That's true. Yeah. So So now the next thing is next step would be to separate this into the x variable and y variable for further process. Okay. Just separate the features and target variables. Okay. So just do that. Everyone, just do that.
I have a question here in separating this into X and Y.
Yeah.
We can use the drop method also.
Yeah.
Okay. So in this, this iLock way, what we are doing.
Yeah.
If let's say the target is in the middle column.
Yeah.
So then we need to actually count the columns, and is there a simpler way of doing it?
So drop is actually more correct here because the advantage of pandas is that columns are names.
Right.
And if you still use the array indexing syntax, then you are losing that advantage in a way.
Okay. Thanks.
So drop always is better. Yes.
Okay.
That's true. If you have to, like at the end point, you can convert it to the array format because array format is a little faster. Okay. So, but at the end, initially we should not, like as Jadil is saying that's a correcting. If it's in the reductive format, it's easy to do those things, and drop is a much better approach. Okay. So it's just that whoever is creating the collab, he has different approaches. Let's say here also, I was just trying that to use unique. Okay. So the thing is like they have used that state method. Just just he converted it to, I mean, just put it in the state method. So again, using this one also, we can get the unique values. And yeah, but usually we do that like that only. I mean, dot unique is a good one. I mean, we in general we use that. Okay, so it is like that. I mean, there are many and usually we use that dot drop only. Okay, so and we usually don't do convert it in the array format at the first step only. So it's just that we should know all the methods. I would say that only. I mean, yeah. So just divide the data set into X and Y, and yeah, whatever the code you are using, just say that. Okay. Yeah, it would be good. I mean, just whoever is writing the code, no, just to share that code in the I mean, yes, chat box. Okay. Otherwise, there are other apps also. I mean, if you guys want to use that, yeah. Okay, so yeah, data separation is done. I mean, so it might be that you haven't said that class actually. I mean, you haven't said the names properly. Yeah, name the column. Yeah, just name the column correctly. So it might be possible that you
Yeah, I used a small C class.
yeah, that's why I'm saying that, yeah, you might have used the capital C, something like that. So
Sir, can you scroll up?
yeah, here. Everyone who will think that, yeah, just go along with us only. I mean, I'll wait. No issues. Okay, so yeah. So yeah, just take the shape of your data set. Okay. So I mean, just to cross check that whether it is done properly or not. Okay. So for now, yes. So now, yeah, after doing that, just we can proceed with the like different unique values in each column. Just cross check that. Okay. And like how many different unique values are there in each column? I mean, including the target variable and also the yeah. In also you have to in features also you have to check. Okay, because in this time like we have features also with the fixed number of unique values. Okay, so maybe just practice that. So and yeah, it would be a good idea. I mean, if whoever is going with new approaches, they can yeah, mention that also, or yeah, they can discuss that. We can discuss that also. Okay. Yeah, the quick approach. Yeah, in one sentence only you can check all the unique values. So he has run the for loop. That's a good one. So these things will work. I mean, these things will be really helpful when you have, let's say, 20, 25 columns, something like that. So 4, 5 columns, here we have 4, 5 columns. So you can go with that. But ultimately, like when in general, we have more than 20 columns. So then you have to, definitely you have to use the form. I mean, how many times you will type this thing? Okay. So yeah, just someone says like how many. So here we are seeing that in target variable we have 3 unique classes. I mean the class B, class L, class R. Okay. So yeah, left. I mean yeah, I'm assuming that it would be L is denoting left and R is denoting right, and B maybe it may denote balance, something like that. I don't know basically. Yeah, just I'm also trying to predict. Okay, so we can see that in all the classes, I mean in all the columns we have value ranging from 1 to 5. Okay, so yeah, in the column 0, column 1, column 2, column 3, in all the columns we have values ranging from 1 to 5. Okay, yeah, now yeah, so it's good that we have seen that. So let's see, I mean how many values of how many unique values of class B we have. I mean how many class B we have, how many class L we have in target variable. Okay, so just plot it. I mean just plot any plot. I mean usually here they have done the count plot. So can you see that any other plot which you can use here? Anyone? Pie chart, yeah, pie chart would be also a good idea. Yeah, but here actually, yeah, like we have 3, 4 only, so maybe we can represent like that for a small size. But yeah, when we have large number of, I mean, yeah, I mean 5, 10 columns, yeah, 5, 10 different values. So then it's not a good thing. Yeah, white trend dot six, yeah, histogram. I think yeah, we would be getting the same. That's right. Okay, I would not have to do it in the white. Yeah, so using white dot hist, some we are getting this type of shape. So yeah, that is also a good, I mean, yeah, alternative way. Okay, so I think if anyone is still lagging behind, they can say that okay, so I can, if they will say that I will copy the codes in the chat box. Okay, because yeah, we haven't gone too far, so you can say. Okay, in the next step we will just divide our.
So can we say that there is a class imbalance here?
Yeah, class B is yeah, I mean it's 300 only and one is 50. So I think yeah, 160 is there. I mean.
So are we going to do any data transformation here as well?
No, we haven't done that, but I think so. I would also like to take suggestions from there. So in these kind of cases, I mean, see, like we have 300 around, yeah, 300. So 160 is there, no? Yeah, 160 around. I mean, 6-7%. No, 16% actually.
Actually, total it's less than 10%.
Yeah. Total is less than 10%. So I mean, so I think I can't say. I mean, should we use that understanding over that data analysis technique or not? I'm not sure. I mean, for this much, I mean, data simply we do see we do that class imbalance like we had. I mean, like around let's say in spam email or anything, like we have thousands of samples, and in thousands of samples, I we have 1 or 2 samples for that, 2, 3 samples, something like that. So in those cases, we do that. We use the class imbalance techniques and all. So I'm not sure about this one. Do we use that, Jadil? I mean, yeah, you can.
This data is imbalanced, and there is nothing special, no special technique as such for something like this. You just change your metric so that basically what will happen is if you use some sort of a simple algorithm here, it will never learn class B because the samples are not enough or something like that, right? And then what will happen is that if you simply take since class B is less than 10%, if you simply compute accuracy, it will always show up more than 90%. But that is not good because you are not learning one entire class at all. So let's say you get a stupid model which only learns R and L. It doesn't learn anything about B.
Yeah,
It will still give you an accuracy of more than 90%. So
yeah,
the trick here is to change the metric. Find out a metric which actually gives, which penalizes
more. I mean, yeah, but
for imbalance
yeah.
in the classes, and F1 is a good example of that.
F1.
So whoever's doing a Kaggle project, you'll see that also in that particular that dropout problem also we have massive class imbalance, and there the metric actually is average F1 per class.
Okay. So, yeah, one thing is there. I mean, yeah. So accuracy can't be a good thing. That's true. I mean, usually you see in that in these kind of shapes. I mean, in these kind of imbalances, either precision or recall becomes a good metric. Yeah, good metrics to check that. And yeah, F1 score is since it's a balance of all those things. So yeah, F1 score we can use that to check the check the accuracy or yes the effectiveness of our model, I would say. And one thing is true. I mean, I also haven't used I have also haven't used. I mean, I would say the imbalanced data set issues with these kind of shapes. I mean, whenever we have used those things, no, like smart and also in those kind of shapes. I mean, when we have, let's say, like thousands of samples of class 1 and like 2-3 samples of class 2, something like that. But whatever Jadis said that's true. I mean, in these cases, like your model, at least a weak model won't learn the class B. So I would also say that, and I would also I would also check our accuracy and all. I mean, not the accuracy. I mean, other matrices value after applying some imbalance techniques and before applying those techniques. Okay. So but anyway, that's a good point. And whoever has raised this question. So I think this is it. Who raised or who raised this question? Hello. Who raised this question? I mean. Hello. Yeah.
I think it was Prashant.
Okay, Prashant. Thanks, Prashant. I'll also check that. Okay.
Yeah.
Yeah, I'll also check that. I'll also check this question after this. Yeah. So the next question would be to just divide your data set into X and Y. Okay. Just take 20% as a test size. Okay. And random state value 42, 32. Okay. So so after dividing the data set into train and test, we are seeing that we have around 500 samples for training purpose and 125 samples for test purpose. Okay. So which is around 80% is coming to the class for training purpose. So okay. So now splitting is done. So after that we can proceed for the next step. Or maybe I'll wait for 2 minutes so that everyone reaches at this step.
So Jimmy, this is actually this particular split that we just did. That is an example of why you should use Stratify properly.
Okay.
Check the distribution of the classes in Y train and Y test. It's not a massive difference, but there is a difference.
Okay, so how much difference it is there? So that I mean after you
two or 3% everywhere. So for example, in YTR, L is 46%, R is 45%, and B is 7.6%.
Okay.
But R grows in YTA in Y testing. R grows by 1%, right goes down by 1%, and B goes up by 2%. So
actually, I was also not using stratified. I mean, when you told about that in the last session, Then only I was also focused on that yeah, parameter. Okay, so but yeah, I as I told you that I was using this one, but I just okay, yeah, we can do that also right now. So how it is mentioned like that?
Stratify equal to y.
Okay, okay, so yeah, stratify. It's telling me the
Smallest.
okay.
Small y.
So yeah. So there would be underscore or what?
No, just y.
Yeah.
That's the array on which you need
Yeah,
to
yeah.
stratify. That's all.
Yeah.
Now
So
you check the proportions of the classes in y train and y test. They should be very similar. Without that, you'll get some difference.
yeah.
And here
So
it's pretty straightforward. It's a smallish data set. When you have more classes and more samples,
yeah.
this goes much longer.
Okay, yeah, that's true. I mean, yeah, we should teach others also. I mean, this one. So in the next last session only, Jaydev suggested that we have a parameter which is known as stratify. So with the benefit of this one is that if data, if we don't set it to the, I mean, y or something like that, we don't enable it, then data is not, I mean, it doesn't split data in the exact proportion. I mean, let's say, as the Jaydev is saying that, or I mean, yeah, that's the true fact only. So in the original dataset, we have, let's say, like we had class B in let's say 10% and 40% class right and 50% yeah 50% class left. Okay, so like that, if this is some proportion is there, so after the split the same proportion should be there in the train case and test cases also. But what happens is when we don't set this stratify equals none, then then our split method doesn't follow that. I mean, they don't split in that exact proportion. Okay, so ideally we should do that. Okay, that I also learned. I mean, yeah, in the last one only.
Sir, is it similar to that stratified shuffle split that we do?
Exactly. The
But
word is
there it does it in every fold, and here it does once. Is that the difference between the two?
yeah. That is the only difference. I mean, they are also like whenever they in shuffle split, state by shuffle split, they shuffling it, and again they are distributing like that only. I mean, they are doing stratifying it. Okay, so the same the stratify word is doing the same thing here. Okay, so the main job of this word is, this parameter is to distribute in the equal proportion. Okay. Yeah. So it's a good thing. I mean, from next time onwards, I will also do that. I will also use this one. So yeah. So the second question after this, the question says that train a decision tree classifier model with random scores, random state equals 0 and default values. What are the train and test? Okay, one more thing. I mean, so we need to make a good idea. I mean, see, this time also, like in the one of the question, one of the OP questions, we said that random state equal to RS. It happened actually just because like in the initial steps we had set random state equal to RS and I mean random state equal RS equal to 42. Okay, so we used everywhere that value only. So, but somehow like that got copied in the questions also. So we need to be a good idea. I mean, if we just mention the random state at the first step only, or I mean the common random state value for all the questions. Hello.
Yes, you're audible.
Yeah. So I think that we can do. I mean, yeah, to avoid this kind of confusion or I mean, yep, error. Okay. But yeah, one thing was that whatever random state value you would use, you will get your answer in the same range. I mean, I had run the for a random state value from 1 to 100. We were getting the answers in the range only. I mean, yeah, for one question was around the alpha values, and so and second question was around R2 score values, I think, for training data. So for that also, that was coming in the range only, but still we ignored that.
Sir, if you don't give random state for each question, I mean, sometimes it's not very clear which place we have to put random state and where we don't. Just like this decision tree classifier. Generally, classifiers, I don't know if they have random states, but in decision tree it is there. So we may not remember this actually, if you give it in the beginning, where to use one and where not to use one.
So yeah, maybe
So
yeah.
that could be a problem, because I did my assignments and that time I wasn't using a random state. Every time I used to run this decision tree classifier, I got different scores. And that is when I realized that it has a random state there.
Yeah.
So that could be a problem.
Yeah, then maybe we have to go like that. I mean, initially we will say that use random wherever the random state is mentioned, you will use that particular value, and then in
Otherwise,
that
we have to mug up where random state is required
In
actually.
that, yeah, but again in that question we will also mention that use random state.
Yeah, that could actually, if that is mentioned.
Random state equals RS or something like that, but and that RS value will set at the beginning only.
Every algorithm, you can just check the documentation in the collab quickly. If it supports a random state, you use it. Otherwise, you don't. And if it is mentioned, of course.
Okay. Yeah. That would do.
I mean, the thing is, see, Jadam, I mean, the thing is like you have experience, so you do that.
No, actually, I don't have experience. I did not, for example, in the OPE, I did not know that one hot encoder can ignore values. I had no clue. I reached that question, I found the problem, and then I said that, maybe there is something that this fellow knows how to, if it has never seen a country called Switzerland while doing the fit step, how will it deal with that country column in the transform step? I looked at the documentation and that's when I realized.
So yeah, that's why we didn't ignore that question. I mean, the logic was like when we discussed, the logic was that people should know like how to cross that. I mean that error. Okay. I mean since after that error only they saying that you have some target variables which is not in the test in the training variable training data set. Okay. So you should know like how you can solve that debug that issue. Okay. So that's why. And I think that's why you got 96. I mean, all the steps. I mean, whatever the issues were there, loopholes were there.
Sorry, I got how much?
96.
Oh, is it? Oh,
yeah.
Thank you.
Yeah. So you didn't. I mean, what you thought? I mean,
No, I thought I thought the scores are not released, but okay, thanks for telling me.
So I told you, no, I mean, that the beginning only I told you, like, I just congratulated you, no, I mean, you got 96, 96. So you were the
Oh, sorry, I seem to have missed that. Thanks.
Yeah, so you have solved all the questions. I mean, even before normalizing it. I mean, after that we normalized it, but yeah, even before normalizing it, you got that much.
So I have a doubt here.
Yeah, please.
This I've used the same random state as what you've used, but my test score for the is coming as 1.
Okay, test score is coming as 1.
Yeah.
Okay, so might be. I mean, I didn't run that code just after that stratified value. So let's see. Yeah. So again, you are still getting a test score as 0.1.
As 1 only, not 0.1.
Yeah, I mean, yeah, just a mistake. I said that. I don't think. I mean, where you have.
No, I also did the stratify and I'm getting the same train and test scores as 1 and 0.728.
Yeah.
Same as what Jamie got. Are you sure your X train and X test are correctly written in the same order?
Here we have used random 42. Have we used that? Hello.
If you're getting the same, I'll debug it because I put it in the same order. X train, X test, Y test. Yeah, it's in the same order.
Test size, stratify, random state, everything is the same.
Yeah, test size is 0.2, stratified, yes. Random state equal to 42, yes. Shapes are okay.
Okay, try running the decision tree once more.
Once more, huh? Okay.
Yeah. Fit, score on train, score on test.
I mean, from the discussion we saw that you use the linear expression. That is what we were supposed to do. And in the question and the last question, there was like the collab was crashing. The thing was that initially we hadn't used that one hot encoder part in that initial question. So at that time we had set question for polynomial degree 1, 2, 3. But after that, like we changed some questions in the pre-processing part. Okay. So due to that, we had said that I mean polynomial degree equals 1, 2. So that's why we ran the code in, using 1, 2, like after change of the code, and we set answer according to that. But we missed it to correct in the questions also, like after the modification. So because at that time it was just configured onto the portal. So that's why we.
So actually, GB, what I'm really curious about is how did you manage to run that grid search at the end, last two questions? Just out of curiosity, I know they are ignored, but third degree polynomial with 200 features is crazy. What happened exactly there?
So yeah, that is what I am saying. That what had happened? No, like initially there were few after the creation of the paper. Okay, so we changed a few questions in the pre-processing part. Okay, due to that, now okay. So now we had this thing. So after that, so when again we debug that code. I mean, when we got the error, we debug that. We changed it to polynomial degree to 1,2, and we run that. Okay, so answer is based on 1,2 only now.
Yeah.
So we updated the answer, but when we updated it in the collab, no. But by that time, the question was already configured onto the portal. So that update didn't go to the portal. Okay. I mean, on the portal, we had to get the question. No? So, yeah.
That particular thing with degree 2 works. That much is within the RAM. Okay.
I think that's why you got the answer also. I mean, your answer is correct now for this question also. I think you had used that.
I don't know. So, but I mean, that was the only choice I had. I thought like, what's the best way to reduce the size of the grid is to remove 1 degree from the polynomial, and it worked. So I was left like last 30 seconds. So I just pasted that answer.
So yeah, that is what was this. I think for the 1,2, it takes around 2 to 3 minutes. Yeah. For that also, yeah, 2 to 3 minutes it takes. Yeah. Something like, or 1 to 2 minutes. I don't remember. So that's why we said that we never got that error because that was the reason. I mean, when we cross check. And also, like I would also suggest, like, I mean, many people doesn't change that. I mean, whenever you use that, no, I mean, you can set that. I mean, turn it into the GPU mode. Okay, so it gives you the initially one logic was working. Whenever you use that infinite loop in this RAM in this collab, no, then it just gets crashed, and then they increase your RAM value. I mean, from 12.68 GB to it just increase it to the double, but now that is not working. So otherwise you might have got the double RAM value for some time. Okay. Here you have the runtime. I mean, you can restart runtime and you can change the runtime type. Okay, so you have GPU, TPUs. Okay.
But how will scikit-learn work on GPU?
I mean, they just provide it. I mean, that's true, but yeah, your but execution speed gets a little faster. That is what I had also observed. But I don't know. But whatever the execution time is, no, it gets improved. I mean, little bit only, but yeah. Okay, let's yeah. So we deviated from our path. Okay, so let's set these values. I mean, yeah, dysentery classifier. Okay, yeah, we trained the model. We got training score as 1 and test score as 0.728. Okay, so yeah, the next question is what is the depth of the tree? Okay, so these things we can check, like what is the depth of the tree, how many nodes are there in the tree, and yeah. So let's first do this. I mean,
So dot get depth and dot max depth would always give the same answer.
Get depth. I mean, get depth can be something like when we after the pruning and all, like we can change that. No, I mean, so
yes, it is the same thing. Get depth is actually returning the tree underscore dot max depth of the same model.
Okay, thank you.
So yeah, you can
inside a function. GB, could you make a cell after that DTC dot get depth?
After this one, okay.
Yeah, just add an empty cell. DTC dot get depth double question mark.
Okay, for that. Okay.
Yeah, this is a very small function. Just do double question mark. Yeah, run that. You check the last line. It is return self dot tree underscore dot max depth.
Okay, yeah.
This is also very useful in OPPs.
This double question mark is meant for smaller functions, is it?
No. For any function, double question marks give you the source code of the function. Just question mark will just give you the docs of the function, the doc string.
Okay. Thanks for that.
Yeah, I also learned these things. I mean, this double question mark thing. I mean, the last time when we are cross checking this collab, there only I saw that. I mean, a single question mark we know that, but double question mark then only I got to. It's a good thing. I mean, these are the things that which differentiate the people. I mean, the people are that like who can. I mean, in the collab only they can check all those things. But people say that yeah, they have to refer some other codes. Okay, so yeah, you can use this get depth and max depth. Both will give you the same value. Okay, so okay, this is the one thing. Okay, so now yeah, after the node count, you got around 251 nodes. Okay, so yeah, is everyone with me? Okay, so whoever was at the start, so are you guys reached till this point, or if you haven't reached, then just ask. I mean, where you are lagging, I'll just directly copy the code and paste it in the chat box. Okay. Dot get depth is okay. After actually we have changed the code, no. So now it is using 10 for me also. Yeah, for everyone it is using only, like it's just that initially we had run, no. Yeah, 247 node. That's one. Yeah, total 247 node we are getting. Okay. So together, yeah. Yeah, dot get depth will give you that 10. Yeah. Depth is 10 and yeah, node counts are 247. Okay. So anyone, I mean, yeah, whoever is lagging, just say, okay, just mention that so that I can paste the code. Or if you guys are with me, then yeah, it's good. I mean, so anyone? So I'm assuming that you all are you all have reached till here. Okay. So yeah, now it's time to plot this. Okay, this picture. Okay. So yeah.
So in this, when we plot this tree, the
Yeah.
values are basically the values of the classes, right? The
Yeah.
38 to 33.
Yeah.
Okay.
Yeah.
And in the same order as we've done the.
Yeah. Class B, then left and the right. B, L, and R, like that. I think yeah, they usually shows like that. No, I mean alphabetical order. Or if it is in numerical, then class 0 and then class 1.
Yeah, BLNR, right.
Yeah.
Okay. But instead of can we in a tree get the class also, the name along with this? Is there a way to do that?
That name I do not know actually. As of now, I don't know any name, any method where we can see that class name. So yeah, can we? So we can get the class name. Yeah, how? I mean, there would be. I mean, yeah, but yeah, I also need to check. I mean, I do not remember that. For that, let's see this one only. We are plotting the tree.
Yes, there is a variable called class names, a parameter called class names that you can set to the list of the
Class
names
name,
in
yeah.
there.
Yeah, class name is there.
Yeah.
You can also use feature names as df.columns. That will make the whole thing a lot more readable.
Yeah, that
Okay.
can be also there. Yeah, features name is also there, class name is also there. So we can set that, okay. Yeah, for feature name, if we don't give the name, then yeah, by default it takes like that. I mean, it's 0x like that. And so yeah, we have features name, class name also, okay. So let's enable it. Just see. I mean, yeah, we have to give the list of string. You know? Yeah, we have to give the list of string. So yeah, so we will get that. I mean, it's just that the diagram will be more complicated. I mean, we will get the more complicated. But yes, we have that. Okay. So till now we just we have built the tree. Okay, and we use it. Okay.
Sir, can you scroll a little up?
Okay.
Sir?
Yeah.
Yes, sir.
Yeah. Here.
Sir, more little.
Okay.
Yes, sir. Okay. Little more, sir.
Oh, ever only.
Okay, sir.
Yeah.
Okay, done.
Yeah.
Thank.
So yeah, we have made this class and all. I mean, yeah, we have just visualized our tree, like how using linear index they are changing that they are splitting. Okay. So after that, let's do that. I mean, just we will use that CCP alpha values. Okay. So we have in sklearn, we have that CCP alpha values. We can calculate using using this function, cost complexity pruning path. Using that, we can calculate the alpha values for each node. Okay. So yeah. So what we will do that we will just call this function. Okay, and then we will get the pruning path during minimal cost. Yeah, we will try to get the all the alpha values. Okay, then we will use this alpha values to check the accuracy. I mean, at all these nodes, we will check the accuracy. Okay, like how accuracies are changing with different alpha values. Okay. I mean, so have you learned about this 60 alpha values in MLT or not? Hello. So no, the thing is like we have allowed our tree to grow fully. No, I mean completely. So that's why it would be the case of wood. That is what is mentioned. Okay. So we didn't set any parameters. I mean, we in our leaf there would be just one sample. So that's why I mean, or that is also case. I mean, it's overfitting because it's so much lower than trend. So that is true. And one thing is like we did stop our tree to grow. I mean, okay. Just here, I mean, we didn't stop our tree to grow. No, I mean, so I think in the leaf node we would have only one sample, something like that. So we didn't set that minimum split. I mean, minimum, yeah, minimum samples we need to do that to do the split and all. I mean, we didn't set any value like that. Okay, so that is what it is saying that we allowed tree to grow completely. So that's why. So have you got my point or what? Hello. Yeah. So yeah. So have you read? I was asking that a cost complexity, a pruning path. Have you read about this cost complexity part in MLT or not? Okay, no. So yeah. Okay, it's better to see both of. I mean, all of us will see that how it is. Okay. So I have just checked that these things, but still okay. It would be easier to check. Okay. Cost. So we won't go to then we won't go to the mathematical part. It's just that there is some values, and once these values increases, it's just like I would say that it is also representing that when these values increases, our error increases. So yeah, okay. So okay, it was covered. Yeah, so it's okay. I mean, we won't cover that mathematical part, but yeah, here we will just talk about this one. I mean, this one's just great. That minimal cost complexity pruning successfully finds a node with the weakest link. Okay, so the weakest link is characterized by an effective alpha. Okay? Where the nodes are the smallest effective alpha are pruned first. So the shape we see that here, just see that. I mean, this figure is enough to understand that. I mean, once this alpha values increases, no, the impurity increases. Okay, so impurity increases. It simply means that our accuracy will decrease. Okay, so yeah. Okay, yeah, just see. I mean, we'll just plot our graphs only. We'll use these alpha values. Okay, so you can just calculate all the alpha values. Okay, then what we will do that for each alpha value, we'll check at that point what is the accuracy. Okay, so for that, what we have done that we have just created I mean, we created a empty list, and in that list we will add. I mean, for we run our this loop for all the alpha values. We will check that for each alpha values, what is the. I mean, we will train our model. Okay, for that alpha values. So have you got my point? I mean, so what we are doing here. So anyone who is confused or who didn't understand, just ask me. Okay, like I can discuss again. So what we are doing here is we are just taking all the alpha values, and at that alpha values we are calculating the we are training our model so that we can check our accuracy of our model at that particular alpha value. Okay, then we will plot that so that we can easily visualize like what happens.
So, but does the alpha keep changing at every node? I mean, is that the reason why we have so many alphas?
Yeah, that is what I mean. For the alpha value is the deciding factor only. In this case, alpha value is the only deciding factor. Okay, CCP alpha value is the only deciding factor here. Just see.
Okay.
So yeah. So what we have done here, like so we just saved all the alpha values. Okay, and at each alpha value we are just trying to plot our data, our tree. Okay, so what we see here is like this is again I have to run this code time. So we got this array of alpha values, and we saved it, and we just ran a loop to train our model at each alpha values. Okay. Now what we will do that we will set all the scores in the training score, test score, and again we will run this loop to save that score values. Okay, to save the training score and test score in the list named training score and training test score. Okay.
So I'm not clear. Can you explain it?
I mean, see
From
what
the
we are.
alpha value step.
So here alpha value.
We are taking the last column of the alpha.
Last column at the alpha. So I mean, just to say what you didn't get, this alpha value why we are taking or what?
Okay. So here we are trying to fit the alpha in for every loop we are getting a separate alpha, right?
Yeah.
We're getting different alphas. So,
Yeah. So for all the alpha values, we are creating the model. So what we are doing that, let's say for these alpha values, we use this alpha values to train the model, and then we check our train score and test score. Like that we are doing. Okay.
okay.
Yeah.
So we have only a single array of alphas, right?
Yeah, sorry. We have.
We just have one array of alphas.
Yeah, here. Yeah, one array of alpha.
So we are looping through each element of it, right?
Yeah.
Okay. And then, okay, got it. Okay.
That's true. I mean, yes, it's just hyperparameter unified only. So here we use that all the alpha values to train the model, and we just save all the our train score and test score for all the alpha values. Okay. So yeah, we will just check that. I mean, we will just try to plot that. I mean, training score and test score, that is nothing but the accuracy. So we'll just try to plot that in the single graph. I mean, how the alpha values are changing, and based on that, like what is happening to the training score and test score, training accuracy and test score accuracy. Okay. So what we are seeing is that the training score is continuously decreasing. As alpha value is increasing, training score is decreasing. But the test score is, first it was increasing, and after that it started decreasing. So that is what we learn here. No, I mean, we have to select the which alpha value would be better. I mean, yeah. Okay, it's a question just. The question usually we ask in a quiz. Yeah. So anyone has any problem in this code? I mean, the codes are simple. I mean, we are just mentioning the labels, titles. Okay. And this one, first we are plotting the alpha values. We are taking alpha values as x-axis, train score as a y-axis. So marker is labeled as O. So that's why we are getting this shape. Okay. And yeah, label draw style. Draw style is something like a shape code. So that's why we are getting this kind of Manhattan distance type of shape. Okay, yeah, you can repeat that. I mean, we run this code, no? This is the shape we are getting. Yeah. So what we are seeing that the first initially when the alpha value is increasing, so that is for sure that your accuracy will decrease. But after for a certain period, I mean, your accuracy will increase. I mean, this is the case of overfitting, no? I mean, so once you are moving towards the optimized model, your testing accuracy will increase. But once this we reach at this optimum point, after that your training accuracy will decrease, and also the test accuracy will decrease. So, have you got my point, or someone can some other person can also try to explain that? Okay, I think yeah, that would be also good one. I mean, continuously I is speaking, so yeah. Apart from that, that is the first case. Hello, any other people who want to volunteer? Like what you got, what you are observing from this graph. I mean, what you are understanding. It's a basic concept. I mean, here also we have learned this concept many times, you know? But still someone try to just explain. I mean, whatever I said, that only or anything, some plus minus would be okay, or maybe the same thing in your language. It will help you to remember for a longer period. Anyone, please try. Okay, again I'm saying. Okay, so what is happening here? See, initially from this graph, what we are seeing that first we are seeing that this is a training score. Okay, so when the alpha value is increasing, your training score is training accuracy is continuously decreasing. Okay, and this one is the test accuracy. So what we are seeing in the test accuracy, first it is increasing, then it is decreasing. Okay, it is like that. So why it is happening? So it this kind of thing happens only when your model is overfitting. Okay. So whenever you are seeing that your training score is training accuracy decreasing and test accuracy decreasing, definitely it is the case of overfitting. Okay. So once this overfitting case ends, then after that, when you will, if your accuracy is decreasing for training data, and the same thing is happening for the test data also, then you can say that your model is moving towards the underfitting mode. Okay. So yeah. So this one would be your optimum alpha value. Okay.
But sir, what is alpha here?
So the same thing, I mean, this cost complexity. Okay, CCP alpha values. So that is the values, I mean, cost complexity pruning path. What is so here? It is helping you to keep set the maximum depth of your tree. Okay, it's the post processing pruning part, pruning technique, which can help you. Okay, to just limit your depth of your tree. Okay, to avoid the overfitting. Okay, so the
Right.
yeah, so the mathematical formula is there, which is I think yeah, it would be mentioned here. So minimum cost complexity pruning there. So that value is alpha. That 50 value is alpha. So I think you can check the mathematical part.
Sir, and why is increasing alpha decreasing accuracy?
So this is a kind of error only. I mean, I would say. So what is happening here is like for different tree depth, see here. This one only I would see. So this is something like this alpha value is something like a minimum cost completely find the node with the weakest link. Okay. So the weakest link is characterized by an effective alpha. Okay. So it is representing that weakest link, that alpha value. Okay. So what is happening where the nodes with the smallest effective alpha are pruned first. So what we do like the nodes which has the smallest alpha values, we first we try to remove that one first. Okay. So I think you will get a more clear idea when you will go through that mathematical part. I would say that, I mean, for here, I mean, for this system, you can say, think like, yeah, this alpha value, once it is increasing, you will, your error will increase. I mean, your, the model is overfitting. So for, you can just try to, you have to just remove the weakest link. Okay. I mean, which is helping, which is making your model overfitted. So I would say that, yeah, you would get a much clear idea once you will go through the mathematical part. That's why I asked you about at the initial stage only. I mean, have you read about this in the MLT or not?
Sure. Okay, sir.
Yeah. So yeah, that is what we see from the graph. Okay. So now, yeah, again we are doing this thing. I mean, how how the number of nodes varying once we are changing the alpha values. Okay.
I can't see your screen, sir.
Okay. Okay. Visual?
Now it's visible.
Okay, so when I was talking about that SQL and part documentation, have you seen that? I mean, when I was that mathematical formula and all for the from the SQL website. Hello.
Yeah, now we are seeing it. So that time we couldn't.
Okay. So I was referring to this. So it's okay. I mean, you have to go through this mathematical part, then you will get the much better idea about this one. For here, for now, you think like, yeah, these alpha value, once it increases, it affects you. I mean, yeah, these alpha value help you to remove the overfitting of your model. I mean, these alpha value help you in that, and to check that, I mean, it helps you to get a maximum depth of your tree. Okay, to set that maximum depth of tree, and based on due to that, you can remove the overfitting problem. Okay, so here we are seeing that what we have plot here. Okay, node count. Okay, how many nodes are there? But yeah, they have plotted like how many nodes are there for yeah.
What is on y-axis, sir?
Yeah, the count of that node. I mean, that is what
And
I'm.
x is?
Yeah, X is a node. I mean, node 0, node 1, something like that. That is what I am also trying to figure out. Okay. But the one thing is that there is a count plot, so it is the x-axis is denoting the node and it is denoting the count. So, but still I'm also, but yeah, I'm also 100% not clear. I mean, whatever say I said that would be true, but yeah, how it is happening? Let me check. How many nodes were there? 247, no?
Yes, yes, sir.
247 nodes we have.
So y-axis, I think, is node.
Yeah. Like it is like a zeroth node,
count.
first node. Yeah, zeroth node, first node, second node, third node, fifth node, something like that.
Right.
Yeah. So yeah, that is done. I mean, yeah, but this one is not making any sense till now. I mean, have you? If any one of you is able to, I mean, infer any information from this one?
So is x-axis the number of samples in each node? I mean, I don't know. Because the last node, the 247, has probably only 1 or 0 sample. 1 probably.
Yeah, that's true. I mean, for the node 250, we have just 1 sample. Just 0. Yeah, for 250 node 250, we have just 0 samples. For
Sir, x-axis is alpha.
Okay, x-axis is alpha. Okay, where we are taking that? I mean,
Because if you see the graph above, you just
so
go up.
alpha axis can't be there. No, alpha value.
Okay, yeah, it can't be.
So it can't be alpha value. So one thing is, it's a node count is there. Okay, so I think the node count would be on the x-axis. How many counts of nodes are there?
But then we have 247.
That is true. But the thing is, this graph is 56 items. Total node count. Okay. It is really already stable. So we are seeing that here 3, 5, 7, 9, 7, 13, 15, 17, 19, all the alternate numbers. I mean, no, it is not like that. I just, so it is node count. Okay, so it is just that in the x-axis we are getting how many nodes are there. I mean, how many 3s are there, how many 5s are there, something like that. Can I see? No. It's okay. For now, I just ignore this one. Okay. Using classificative plot, how the number of nodes varies with alpha. So they have written that it varies with respect to alpha, but alpha is not there. I mean, we haven't used alpha. Okay. So yeah, in the next figure, again the range is from 0 to 10. So but how the number of nodes varies with respect to how the depth of the tree varies with respect to alpha. Okay. So this can be your okay. Yeah, it can be your depth, no? Depth of your tree. I mean, when you had 250 nodes.
Maybe it is adjusting the scale, sir, to put it in the plot because alpha is too low.
Yeah, that can happen. That can happen. That's true.
Because this count is coming in hundreds and alpha is coming is 0.0. So maybe it's adjusting the scale and just plotting. Matplotlib is doing that. Right?
Yeah, that can happen. I mean, that's why I mean, we have to check that. Okay, for now.
Because depth was also 11, so y-axis is showing the depth in this plot where you are
This
Yeah.
one, no?
Yeah.
Yeah, that's true. I mean, yeah, that is what I mean. The changes happening in the y-axis. Initially, we had number of nodes like around 50 to 50. That is true. I mean, yeah, we figured out that y-axis is this one only. I mean, yeah, here it is depth, but x-axis we are worried about this x-axis since every time they are talking about the alpha. So yeah, that can be the case. I mean, they have just rescaled that. So maybe yeah, 60. It is more than 60. So yeah. Yeah, I can say that. I mean, 0.06.
Multiplied by 1,000, I
Yeah.
10,000 or something.
Something like that. But yeah, but it is increasing. It is more than 60. So that's why yeah, but it's a different step post plot. No? So maybe they have to just, but still there's some point. Okay, I'll just yeah, I'll also cross check it, and yeah, after that I will talk about. Okay, like we did like we did for PCB values, we will now check different values of max depth. Try all max depth value between 1 to 15 and check and create those many classifiers, store them. Okay, so what we are doing that we are just setting as initially what we did there to avoid the overfitting, we took the help of alpha values, CCP alpha values. Okay, so now what we are doing here is we are taking the help of max depth only. I mean, that's a post-pruning technique and it's a pre-pruning technique. Here what we are doing here is like we are just setting that we are initially only we are setting that we are not allowing our tree to grow till the full depth. Okay, so what we will do here is we will run the for loop, and here like every time we will change the max depth value. Okay, from 1 to 16, so that we can check that like at what max depth value we get the maximum test score and maximum terrain score. Okay, and that we will set here. I mean, that we will save here in the different column, a different list. Okay, terrain scores and test scores. So I think yeah, this code you can also try along with me. I mean, or earlier code, have you got this code, or I should paste it in the group? Hello, because yeah, I think yeah.
So even if you paste it, we can't copy it from the chat.
Okay.
So just
Let's see. I mean, just for now, I can just share the link, which can be read by all of you. Okay. So yeah, for this session, I mean, yeah, well, I'll keep the link, and yeah, after that I'll remove that link. Okay. For now, you can just copy all the code. Okay. I mean, whatever you have to do. Okay, so like that, we just got the CLF scores for this one. Okay. So yeah, now we just do this one. I mean, this part. Okay. I'm just take the for different max depth value. You just take that score of your model. Okay, accuracy score of your model for the training data and as well as test data. So this graph is little clear. I mean, here they have used the stars for the. So let's do. So was that 0 or 1? So here we try to just plot that plot the train and test score. What we did here is like we just change the different max depth value. Okay, and we just check that how much accuracy we are getting. Like after this value, I mean after 8, we are seeing that our max depth, yeah, our training score accuracy is reached till 1.0. Okay, and the same thing, but here also after that, our after depth of 8 max depth, when we set the max depth equals to 8, then our accuracy is reaching towards the point till 0.7, and after that it is not increasing. So that we can observe again. Here we can see that our maximum accuracy, yeah, we are getting maximum accuracy around when we have max depth around 4. Okay, not around actually, when max depth is 4, at that point only we are getting the maximum accuracy for the test score. So it is the critical point. I mean, yeah. So before that, if you take any value between 0, 1, 2, 3, it is the case of underfitting, and after 4, it is the case of overfitting. So I think, yeah. So have you guys reached till this point?
Yes, sir.
Yeah. Yeah, next, I think, yeah. Let's move to the next part. I mean, so build a new model with max depth observed equal to 3. Okay, so they are saying that they are taking that to the 3. Okay, we'll try for both. Okay, we'll check like how much value we are getting for the 3. Earlier it was 0.776 and 768. So one thing you saw that, I mean, when we use that stratified equals to stratified equal to y, so we are getting the better accuracy, because it is just like initially we won't had that much. I mean, we didn't get all the values in the exact same proportion as we had in the our whole data set. Okay, so okay, let's just change this one. I mean, okay, we just save this one. Okay. Let's change it. Let's change it to 4. Okay. Okay, sorry. So we are seeing that, yeah, the max depth is 4 is the more accurate, and yeah, here we are seeing that 0.76 is the testing score and the 0.83 is the training score. So yeah, so it is 4. Okay, so take it to 4. And yeah, probably we should remove this one. So yeah, so we have done till here. Okay, now it's time to plot the confusion matrix. Okay, so here we are seeing, yeah, since it's a multi-level problem. Okay, yeah, so this is what we have got. I mean, we have blue. I mean, exactly we predicted 2 blue models. Okay, I mean, and as Jade was talking, so here we can see that 49 pieces are there. Okay, no, sorry. Yeah. So initially we were talking that we will predict most of the values wrong for class. Okay, for class B we are saying, no? Yeah. For class B, we are saying that, yeah, all the B values were predicted negatively. I mean, we didn't predicted any B value. So that is what they were suggesting. No, I mean, so it is another point. It is next. I mean, indications that whatever Prashant you said. No, it is the next indication which is saying that, yeah, we should have to use. We should use some techniques to manage this imbalance of the data. Okay, it's another indication. So are you there, Prashant? I think he's left. Okay, so it seems he left. Yeah. So whatever he was talking, it is showing that, yeah, we should see about that. I mean, we should handle some. We should use some other method or something, some technique to remove this error. Okay, because see here, none of you our model never predicted class B. Okay, we had 10 samples in our test data set, and our model never predicted class B. Okay, every time it predicted like L or R. So that is what I mean. Jagger was suggesting that, yeah, for weak learner model, it won't work. I mean, see here.
Sir, how would you fix this?
Yeah, there are different techniques like SMOT and all. I mean, that imbalance handling techniques are different. I mean, we have techniques. I mean, we haven't covered that, no? Hello?
No, in fact, feature engineering also, I didn't think we went into depth.
Okay. Yeah, in future we don't went into the depth, but imbalance and how to manage data imbalance, that is in the session. I mean, that would be in the week 10, I think. Yeah, that is there. When we were creating the materials, so that time only I remember, because last I hadn't taken the week, sorry, so I can't take it. But yeah, I think there were 2 slides on this one. I mean, how to manage the data imbalance. Okay. If it
Yeah,
would be
but
there,
there were no collab on it. There was just some theory of
okay.
they just showed the Smoot and some slides on Smoot, but how
When,
to actually handle it, we were not taught.
which week? Which week they have shown it?
I think the first week only they showed some this thing.
Okay. There would be, I think, they would have shown you the smart techniques and all. I mean, how it works. There are 2-3 techniques, and as they said, no, here we have to use different evaluation metrics can be the criteria to check that. Okay, and yeah, I'll also try this one. I mean, with using the different techniques. Okay, and yeah, I'll try to show that also. I mean, like how I attempted different techniques and yeah, whether I got some better accuracy or something or not. Okay. So yeah,
Okay.
it is a task for me. But nicely he pointed out that, I mean, yeah. Because usually we see that this kind of imbalance technique, I mean, you see these things usually, I mean, those on those data set only, like that spam mailed and all. I mean, where the like there are very high size of like we have the thousands of cases of class 0 and just 2-3 cases of class 1, something like that. This kind of imbalance we see, but we usually this kind of imbalance we just ignore. But yeah. Okay, so yeah, build a new model with specificity value observed, specificity alpha observed when above 0.02 equals random set 0. Okay. So now what we are seeing here, that initially we did that, no? I mean, we are trying each and everything. I mean, see, first we saw that yeah, from this graph we see that maximum depth value. Okay, and we train the model using that. Okay, now let's take about this alpha values. Okay, it is somewhere around this one, so we will use that alpha value to train our model. Okay, to check that at that point whatever accuracy we are getting. So I think that would be same only. So yeah, 0.02 is taking, but I think the exact value is something different. But still, let's see.
How to find the exact value, because we are just doing by visual verification inspection. So how do we?
Yeah. See, what we did here, like we just said, we saved all the errors. I mean, we just saved all the values. I mean, see here. So what we did there, we said that all the training score and all the test score here. Okay. So we will check that what is the maximum value of test score. Okay. At that value, we can check what is the alpha value.
Okay.
Data. So we have plotted here, so to easily see that it is not 0.02. See, 0.02 is something here. So we are getting the maximum accuracy somewhere here. Okay, so we can check that, and exactly we can see that at this point only we are getting the training accuracy, test accuracy around 0.78, something like that. I mean, 0.78, somewhere around that. Is it directly visual from the graph only, no? So what we are doing that we are writing the code to just print this one only. Okay. So yeah, let's try to.
But in this graph, sir, I have one doubt. Why is it not 0.03?
Yeah, sorry. Why?
Because you're reducing your error. Sorry, the accuracy is reduced. Okay, sorry.
Okay, yeah.
That's 0.01 only. Right.
Yeah. Yeah. So let's move to the next question. Okay. So yeah. So I think yeah, this one is left. So yeah, that is what we plotted here. Okay. Once we plotted different alpha values, and we saw that I mean which kind of confusion matrix we are getting. So here we are seeing that yeah, again it hadn't plotted any values. I mean it was not able to predict any class B. Okay, accurately. I mean just 0. It is 0. So the same thing it is saying that okay, class weight to be balanced in the train. Is there overfitting? How many chances are of balance target in the test sets are correctly predicted? Okay, so yeah, let's try this one. I mean, the same thing they are saying. No? I mean, build policies observed and random set equals 0. So print the trend and test code. Is there overfitting? How many chances of balance target in there? So I think same thing it is. So it's just copied again. So yeah, so okay, so they have now, after that they have just yeah, this is also a technique to just do that. I mean, see here, so we are providing the class weight to different class weight for different class. Okay, so here we are providing class B as a weight 1 and other classes weight as 0.1. Okay, so here they have used that. I mean, whatever we were discussing, it is there in that this collab also. I mean, this one just repeat. Okay, so what we have done here is we set that class weight. Okay, so this is also a parameter. I mean, this is also a parameter in decision tree classifier. Okay, so we are providing that weight here, and we will just see like whether we are getting we are getting any improvement in our accuracy or not. Okay.
So which means we need not do it in the test train split, the stratified what we done. We can do it in the classifier itself. What weight to give to each class.
Yeah. Yeah, see here, this is something like when it is plotting your that is different, and this one is different. I mean, see that, yeah, you can do that also. I mean,
I can take out the actual weights and put it
yeah,
in the classifier only.
yeah, you can do that also. I mean, I would say, but see here the benefit of this technique, I mean, whatever we are doing here is like we are providing little extra weight. Like, I mean, see, initially you had 100 samples. Okay, just think like that.
Yes, sir.
Just wait. Okay,
Yeah, it's okay because B was very under,
yeah,
represented.
undersampled.
So yeah, so they are increasing the weight of B.
Yeah, so here we are increasing the weight of that and
reducing the other two.
Yeah, reducing the other two. So the thing is like, see, this is a particular case. Okay, so where we saw this case. Okay, but it's always a good idea to know that your test strategy is just replicating the training set. I mean, just your test case is replicating your original data set. It is like that. I mean,
right.
Yeah, so that's why it is always a good idea to use that. Here you if you want it that stratified equal to y, still your model will give you the good accuracy here. But for other cases, because here we have class weight, we can set class weight from here also. But otherwise, we should use that.
No, I got the distinction, sir. That was just to represent the train and test in the same proportion. This is basically something like SMOT only. This is balancing your.
Exactly.
Right, got it.
Yeah.
Right.
So yeah, so after that we can see our model accuracy. So now we are seeing here that we are able to predict 8 class B. Okay, just see. I mean, just after providing the extra weight to class B, we are able to predict the class eight samples in class B. So it is a huge improvement. I mean, now we are able to, I mean, yeah, around 80% data, but still at the same time, just see, I mean, how many wrong prediction is also going to happen. I mean, 35. Earlier it was not there, no? No, it is also, earlier also it was there somewhere near to. Oh, they were not predicting any class B, no?
Yes, sir.
Yeah, so they are not predicting any class B. So I think, yeah, these things of this kind of balancing we have to do. I mean, we have to, we are the judge. I mean, we are the who have to set this, how much weight should be given to class B, how much weight should be given to class L, how much weight should be given to the class R. So, I mean,
but
we have
it's
to,
only a slight improvement, sir, because not much.
yeah, exactly. That's true. I mean, see, if we are going to, if we are able to predict 8 class B accurately, but at the cost, at what cost? I mean, we are predicting 70 wrong. We are going to do that 70 wrong prediction also.
Right.
Just to get that 8 is good prediction, 8 right prediction. So that is also not good. I mean, we have to change this weight. I mean, we have to reduce the weight of class B and increase the weight of class L and R a little bit. So yeah, we have to set that trade-off. I mean, we have to reach that stage. I mean, optimum stage, I would say. Yeah, that is what is the case here. Okay, I think, yeah, that is all about this week 9 SWI session. Okay. So anything specific, anything else you guys want to ask, or so you can ask, I mean, regarding anything, or we can stop live streaming also. Yeah, I mean, yeah, then also you can ask if there would be question like that. Okay. Or any other doubt, any about the OP, then next quiz is in the next week only, no? Quiz 2.
Yes, sir.
Yeah, so quiz 2 is also coming. Yeah, I think, yeah, that is the case. Okay, so what would you like to, I mean, for the weekend, what should we do? I mean, should we take both session at the same day, on the same day, or we should, because the LWS session would be for weekend would be on Saturday. So what should we do? We should prepone it, we should postpone it, or we should keep both session on the same day only.
Postpone it, sir, please.
So postpone or prepone? That is the question. Prepone or postpone?
Next week, everyone, I think, will be preparing for the quiz on.
Yeah, that's why. And we also don't want like to sitting alone or with one two people and take the session. So that's why I'm saying that. So whether we should prepone it on, I mean, we can take it on Tuesday also, or maybe a Thursday, or maybe next week. Because otherwise, next week you have to take, we have to take 3 sessions. So we are fine in both ways. So it depends on you guys. I mean, whatever you guys will say, we can do that. But definitely we won't try to take the session on the Saturday. Next week, I mean, next week or next to next week.
You'll have to ask others. I would prefer next to next week because then it is the final and we are ready for all the load. That's it.
After quiz 2, sir, next to next week.
Oh, okay, I got you. Yeah, then we'll plan like that. Actually, yeah, let me ask about the slot and all. Like when we have the slot, okay, based on that we will decide. Okay, so yeah, that's all about the session. Any other questions or anything else? So this in the quiz 2, the syllabus would be till week 8, right? Hello.
Yes, sir.
Yeah.
Till 8.
Yeah. Okay. Thank you, everyone. Yeah. Bye all.
Thank you, sir.
Thanks.
Hello.
Yeah. Hello. Thanks.
Yeah. Yeah, sir. Actually, I have a serious question.
Yeah.
Yeah, actually, I was finding difficulty, finding null values in data frames and bunch object. Can you just tell me the syntax for that?
Is null is there. Okay. Dot is null is there. Okay. So okay, I'll just see. So okay, let's see the screen. Okay, is null is there. So yeah. Okay. Just see if I'll interpret. Let's start open. See, I always say that you just write all these things in one page. Okay, this is a small thing. I mean, dot is null, dot is this thing. I mean, just here. I mean, just unique values, something like length of unique. Just put length. Use this. I mean, just all these things. Just keep it in a one collab. Okay, so which can help you. I mean, this one is on this. Okay, so what it is doing here is dot is null is there to give that whether it is it will give when you will run it without sum, it will give the true false something like that. Okay, so but when you put the dot sum here, it will give the total count. I mean, alcohol has 65 null values, hepatitis B has 195 null values, like that. Okay,
so this is for data frame, right?
Yeah, for data frame.
What will happen for bunch?
I mean, for tuples and all, I mean, that is what you do.
Yeah.
I mean, yeah, see.
Yeah.
So there also, I mean, you can't set that null value in that. I would say before doing that, just remove that null value. I mean, before converting into the ND array format, I would always suggest that. And for their case also, I can use that is null.sum. Okay. See, in this one only. See, before doing that, always like we just remove all the null values. Okay. So you otherwise you won't be able to do that. I mean, just save it in the data numpy ND array format. Okay. See, we all do those things no before setting it in the y and x. Okay. Here also you will see. Here also still if you would convert it here no like this, then you will get you will be able to do that. I mean, because here we haven't converted into data frame format. I mean, here we haven't converted in the ND array format. Okay. So once we convert this in ND array, before that only we have to remove all those things. Okay. So any other thing or anything specific?
The same syntax will be, let's say I have loaded from sklearn only some data sets. Let's
Yeah.
say load breast cancer. Okay.
Okay.
So
Okay.
that will be a bunch object, right?
Okay.
Yeah. So how to perform there if I want to find out the null values, or I want to, let's say, replace it, then how to do that in bunch object?
In bunch object. Okay, just let's do that.
Yeah.
Let's see where. Hmm. So you want to set it as a true or what?
Yes, I want to check that if there are some null values present or
Okay.
not.
So where we did the mistake. Okay. This is invalid. Okay, so this should remove the star. Don't need that. Okay. But I have to just try the thing. Still it's the same. That will be okay. Actually, data fix, but it's work now. Yeah. Yes. That.
So you have misspelled dataset. That will be datasets.
Okay. Okay. I copied from there and there. Yeah, it's okay. I mean, why it is happening. Okay, it's okay. I don't know why it was taking like okay. So load data. See that is instead of writing everything on. No need to type out. See, so what we are doing. I mean, target we have already set. What they are trying to do. Don't know. I mean, just remove. So it's cool. Okay. Save this one. I mean, what we have data dot This one, data dot target is for the y, and for x variable, what we use usually then
data we use normally.
data dot data. Yeah, data dot data. Y equals data. So you are saying that okay. So it is the so it is the ND array format. So that is what you are saying.
Yes.
First thing is that you can directly convert it in the edge frame. Okay. So and after converting it, you can check, or maybe when you said that return xy is true, no, you can use that one or that terminology also here. Okay. So I mean, are you getting my point or what? I'm saying something.
No, sorry, didn't get you. There is background noise. Can you please repeat?
Yeah, let the training go. Okay. So yeah, hello. So see, here you can do two things. I mean, first thing is that you can just state that I mean, just convert it into the ND, since it's an ND array format. Okay. So you can convert into the data frame format. Okay. And then you can remove that. Okay. Otherwise, also in the NumPy, we have methods to remove these things. Okay. So to remove the non values. Okay. So what how it does that? Here we have method like is man. Okay. I mean, yeah, something like that only. Okay, is man. Here I think also. Okay, so there would be some methods in an umpire format also to remove that. Okay.
Okay, I will check it out.
Okay, I will just okay. So it's in an umpire format. Okay, or otherwise also we can do that. I mean, we can check that null values. Okay, so this is the to check that. Just to state that null values, no? It is like that. Okay. Okay, so there would be something. I think I also I'm just forgetting the method. I'm not no method is coming in my mind actually. Okay, see this thing. Yeah, none is there, so that is what I tried, but I think why it is in the rest. Maybe I didn't do this. So yeah, that is what it is working. So we are able to see that there is no nan value. Have you got that? I mean, hello?
Yes, sir, I got your point.
Null is there in your normal data frame format. So here we have is nan. So what's the mistake I was doing that I put x at the first place. Okay. So yeah, that was
okay.
Okay.
Thank you so much.
Okay, yeah. So yeah, any other thing?
Yeah, actually I did that. I didn't get this function is nan. I did that, to bringing that columns name and equals to 0, but that was a long syntax.
Yeah, each man is there for numpy format. So basically, I always suggest, I mean, see, the otherwise just the best part of the data from format is, visibility. Okay, we have easy codes for that. So I always suggest you to use, I mean, just convert here also, like you can set return x equals true, so that directly you get in that format. I mean, you will get to all the data set in the data frame format. Okay, So that would be, I also noticed like why the code was not working. Okay, so but the thing is like when you will get in the data frame format, no, it's easy to solve that. But the thing, when you it's easy to do the EDA part. Okay, so that's why we do this one. We set the convert it in NDRS format at the later stage. When you have to just train the model. Otherwise, always prefer at least for the EDA part data frame format only. Okay.
Okay.
Yeah,
Okay.
that is all.
Thank you.
Yeah. Thanks. Bye all.